Yes, good morning, students. So, in the previous the class, we have studied about a binary synchronous communication, the frame format. Another one is a PPP frame format we have studied, and now we are going to see about a DDCMP. So, that is a digital data communication message protocol. Okay, so this is the same synchronization fields are there: the class, count, header, body, and CRC. So, these are all the different fields. Already, we are familiar about that. Now we are going to be see about one of the field that is called as a count. So the use of this particular field, that is the number of bytes contained in a frame, can be included as a field in the frame header. So the DDCMP protocol uses the count field. That count field specifies how many number of bytes are contained in the frame's body. Okay, now one drawback or the danger with this particular approach is that a transmission error could corrupt the count field. If the count field itself is corrupted during the transmission, in which case the end of the frame would not be correctly detected. The end of the frame would not be correctly detected. Okay, the receiver will accumulate as many bytes as the count field indicates. If the count field has corrupted, so the number of that bytes it is going to receive as the bad count field indicates, and then the use of the error detection field to determine that frame is bad. Okay, so this is sometimes called as a framing error. The next one here, we are going to use bit oriented protocols. We have studied about byte oriented protocols. Now we are going to see about bit oriented the protocols. Okay, so HDLC is a bit oriented protocol, so that everything here you are going to be count in terms of the bits. So in the byte oriented, you are counting it in terms of the bytes. Here you are counting it in terms of the bits. So HDLC is a high level data link control. Okay, high level data link control. It is a bit oriented protocol. So for communication over a point to point and a multi-point links. So HDLC defines the three types of the frames. One is the information frames, what you call it as the I frames. Another one is the supervisory frames, we call it as the S frames. Another one is the unnumbered frames, we call it as a U frames. But instead of discussing all these three different S frames, I frames, and U frames frame format, so we will discuss about only the general format. So this is the general format of HDLC. Is it clear? So each HDLC frame is going to begin with the sequence. Okay, and it is going to end with the sequence that is going to indicate the flag. So this flag is going to indicate a 8-bit sequence is there, that is 0. So that is a 6 1, and the next one is a 0, indicating the start of the frame. That is the beginning sequence, indicate the start of the frame, and the same pattern is going to be appear at the end of the frame, indicating this is the end of the frame. So header is going to be consist of information about the sender, receivers, addresses, and all. Body is going to be consistent of the data which you wanted to transfer, or sometimes it may be the control information. Is it clear? Now the CRC field here which you are going to use to detect the errors. Is it clear? That is cyclic redundancy check to detect is there any errors present in the data when it has been received by the receiver side. With the help of the CRC, they are going to detect it. Now once again here we are going to be study about, so the sequence whatever you have used to indicate the start and end of that particular frame. Now the same problem is going to be at the same sequence if may arrive in the body. So if it arrives, it is indicating the end of the frame, but actually it is not the end of the frame. It is not a flag, it is the data. Okay, so for that, what you are going to be do, so one approach here what we are going to be using is a bit stuffing approach. Is it clear? One of the approach what we call it as the bit stuffing. So this problem can be solved by the bit stuffing on the sending side. On the sending side, any time if 5 consecutive ones have been transmitted from the body of the message. Is it clear? During the transmission in the body, if you have having a 5 consecutive ones, is it clear? Now the sender inserts a 0 before transmitting the next bit. So it means that after transmitting the 5 consecutive ones, it is going to be inserting the 0 before transmitting the next bit. On the receiver side, so should 5 consecutive ones arrive, the receiver make its decision based on the next bit what it is going to receive. Is it clear? If the next bit is a 0, is it clear? So you have received already 0 and next 5 consecutive ones you have received. If the next bit is a 0, is it clear? It must have been stuffed here. Okay, so that bit is stuffed, and so the receiver removes the bit which have stuffed, and the next bit whatever is receiving next bit is a 1, then one of the two things is true. Is it clear? So the bit which is stuffed 0, it is going to be removed. If the next bit received is a 1, then one of the two things are going to be happen. So what are the two things? Either this is the end of the frame marker, or an error has been introduced into the bit stream. So by looking at the next bit, the receiver is going to be distinguish these two particular cases. If the next bit received is a 0, indicating the end of the frame. Is it clear? If it sees a 0, that is the last 8 bit it has looked at are 0, 6 ones and a 0, then it is the end of the frame marker. So if it sees a 1, the last 8 bit looked at are like this 0, so all ones, then there must be an error in the data which it has been received. Okay, so this is the procedure here which it is going to be followed, that is the extra bit is inserting here. So that is what you are going to be call it as a bit stuffing. Is it clear? So I think you know about the purpose of using the bit stuffing. Okay, so the next one we are going to see about the another one, the film format, that is what you are going to be call it as a SONET. This is the next one, that is what you are going to be call it as a clock based framing. SONET, clock based framing. A third approach of framing is the exemplified by the synchronous optical network, that is what you call it as a SONET. That is, SONET is nothing but it is a synchronous optical network. So standard, it is widely accepted the generic term. We refer to this approach simply as a clock-based framing or the SONET. SONET was first time proposed by the Bell Communication Research, okay, and then developed under the American National Standard Institute (ANSI). SONET addresses both the framing problem and encoding the problem. Is it clear? So it also addresses the problem that is very important for phone companies, that is the multiplexing of several low speed links into only one high speed link. So SONET addresses the framing problems. As you know that you should know where the frame starts, where the frame ends and all, and already you know about the problems associated with the encoding. Is it clear? So and it is also very important for the phone companies, that is the it will help for multiplexing several low speed links. Okay, several low speed links are going to be multiplexed together, make them to transfer over only one high speed the link. Is it clear? So SONET frames have some special information that tells the receiver so where the frame starts and where the frame ends. SONET link, which is known as STS1, synchronous transport signal 1, it is going to work at the speed of 51.84 mbps. Okay, so we call it as a STS1 frame. Now if you want to see the frame format, here you are going to be see about this particular the frame format. So here we are having 9 rows are there. In each row we are having a 90 columns are there. Is it clear? So totally here 9 rows in this particular the frame format. In each row 90 columns are there. Okay, now in this here the first 3 bytes of each row are treated as a overhead with the rest remaining. So out of the 90, if you remove 3 means 87 bytes are remaining. So 87 bytes are available for the data that is being transmitted over the link. So in each row, the first 2 bytes of the frame containing a spatial bit pattern, and it is these bytes that enable the receiver to determine where the frame starts. Okay, so now the size of this particular frame, if you want to calculate, so totally here 9 rows are there. Each rows is of 90 bytes. 9 into 90 is equal to 810 bytes. So the size of this particular frame is 810 bytes. The overhead byte of a SONET frame are encoded using the NRZ method. So here it is that the bytes of this overhead are encoded using which method? NRZ, non-return to zero method. Using this method, the bits presented here are converted into the signals. However, to ensure that there are plenty of transitions to allow the receiver to recover the sender's clock, the payload bytes are scrambled. Okay, so this is done by calculating the exclusive or of the data to be transmitted by the use of a well-known bit pattern. So what they are going to do here, so here they are going for a process called as a scrambled. Okay, now to allow, that is the transitions to allow the receiver to recover the sender's clock, the payload bytes are scrambled. How it is scrambled? So now this is done by using an exclusive OR of the data to be transmitted by the use of one well-known bit pattern. Using that well-known bit pattern and the data, exclusive OR operation will be done. Okay, the bit pattern, which is a 127 bits long, okay, has a plenty of transitions from 1 to 0. If there is a lot of transitions are there, so automatically there is a synchronization between the sender and the receiver clock. Okay, so the SONET supports the multiplexing of multiple low speed links in the following way. Is it clear? SONET links run at a finite set of possible rates, that is ranging from 51.84 Mbps, that is in STS1, to the STS48. Is it clear? So that is you can write it as a STS48, means it is uh, 48 into STS1, that many number of times. Is it clear? If you are going to use the word as a STSN, so that is if it is STS2, so it is 2 times of a STS1. Okay, if it is a STSN, it is n times of a STS1. Is it clear? So in this way here, we people are able to multiplex the low speed link into the following uh, the way. So here is the one example they have given. A SONET frame is a 810 bytes long on STS1 rate link, while as STS3 rates, each SONET frame is of 2.430 bytes long. Is it clear? So that is 3 STS1 frame. Is it clear? So that is total is equal to 2430 bytes. That is 3 STS1 frames exactly are going to be multiplexed into the single only one STS3 frame. A single STS3 frame is multiplexed into 3 STS1 frame bits. Okay, so this is all about the SONET. So we have completed about the framing. Okay, yes, thank you. In the next class we are going to see about the error detection methods.